concept in physics. Understanding tension helps us grasp how forces interact in various systems. Understanding tension is crucial for understanding how many things work. It helps us design and analyze structures and mechanisms. From simple pulleys to complex suspension bridges, tension plays a vital role. It ensures stability and functionality in engineering and construction. In this essay, we will explore the concept of tension force. We will delve into its principles and applications. We will look at its definition, examples, and how it is calculated. By the end, you'll have a comprehensive understanding of tension force and its significance. Tension is a force that is transmitted through a rope, string, cable, or any other object that can be pulled taut. When you pull on a rope, the force you apply is transmitted along the length of the rope. This transmitted force is the tension force. It always acts along the length of the material and away from the object applying the force. Tension force is a contact force, meaning it requires physical contact between objects. It is also a pulling force, not a pushing force. We encounter tension force in numerous everyday situations. One common example is hanging a picture frame. The weight of the frame pulls down on the string, creating tension in the string. This tension force prevents the frame from falling. Another example is a game of tug-of-war. Each team pulls on the rope, creating tension within it. The team that exerts a greater force creates more tension, ultimately pulling the rope in their direction. Section 4. Tension in free body diagrams. Free body diagrams are essential tools in physics for visualizing forces acting on an object. These diagrams help us break down complex physical situations into simpler, more manageable parts. By isolating an object and representing it with a dot, we can focus on the forces acting upon it without getting distracted by other details. In a free body diagram, an object is represented as a dot. This dot serves as a simplified model of the object, allowing us to concentrate on the forces at play. The forces acting on the object are represented as arrows. Each arrow points in the direction of the force it represents and is drawn to scale to indicate the magnitude of the force. The direction of the arrow indicates the direction of the force. For instance, if a force is pushing or pulling to the right, the arrow will point to the right. When tension is involved, it is represented by an arrow pointing away from the object along the line of the rope or cable. Tension forces are always directed along the length of the rope or cable and away from the object. For example, in the case of a hanging object, the tension force arrow points upwards, opposing the downward force of gravity. This balance of forces is what keeps the object stationary or moving at a constant velocity. Understanding how to represent tension in free body diagrams is crucial